Hello everyone, this is just a quick introduction to the STDIO library, which will allow us to use serial communication from our microcontrollers back to the computer. This will be an amazing troubleshooting tool so we can send messages back about what buttons are pressed, what stage of a code we're in, and gives us a lot more ability to look at our code and how it's working beyond just turning on or off a light. We can send much more complex information back, monitor variables, and things of that nature. So the good thing about this STDIO, the standard I/O package, it's very similar to what we used in Visual Studio in our C programming course, and it's very easy to implement. By the end of this introduction, we're going to see, in general, how to use the printf statement. And then the 4B lecture will go into the details electrically of what these serial communication packets look like as they're passing through the wire. But in order for us to get started by using it, we really just need to know what is serial communication. So we're going to talk about just serial data transfer in general, the library that facilitates it. And then where on our board this comes from, what hardware allows us to send serial communications, and then briefly refresh what was ASCII data format, and that allows us to send characters. So again, if we're wanting to send information between devices of some sort, whether it's our Arduino Mega boards, the Atmel 28560 microcontroller, back to the computer, or talk to a screen such as the one you have in your lab kit, talk to a GPS, or any kind of other instrument, serial communication allows us to pass that information around. Printf is a pre-made function that sends arrays of characters in a fairly straightforward way. For now, we will lean on the printf functionality for sending strings of characters. Later on, and especially in the sequel class to this, ECET 279, we'll really get into the nuts and bolts at the ground hardware level of how to work with memory and send sequences of characters. But for now, we're okay with the pre-made solution so we can facilitate learning more about the flow of our code. Serial communication is how we communicate with all kinds of devices. And the printf function can be used to send commands more than just a string of text, but maybe a command to be received and acted on, like move a cursor from one side of the screen to the other, or show an image like we see on the screen there. GPS modules can communicate with microcontrollers, send their information regularly on serial channels. We interact with SD cards and music players, and even over USB itself in forms of serial communication. In fact, one of our serial channels on our board is hardwired to the USB connection that leads up to our computer. So we do have a communication channel that we can connect to directly, but we actually have multiple serial communication pins available, and we'll make use of more of those as we go. So it's a very cheap and reliable and very well tested historically method of communication. Digital communication, and here we see just some more types of devices that can communicate serially. And serial communication, the serial communication standard, is what allows so many devices to be swappable with our microcontrollers, because they all communicate in the same way regardless of their functionality. So all of these devices shown and many more communicate through serial communication. Some devices can only receive, some can only transmit, and then others do both. We'll talk about those modes of communication a little bit later on, but for now we'll just talk about transmitting serial data and what that looks like. On our hardware itself, we've talked previously that many of the port pins have alternate or specialized functions. You can see on the board along the right side, if you're looking at it, I'm looking down at a Mega board right now, we have a number of pins that say TX and RX down on this side. TX and RX 1, 2, and 0 as well, shown there. Those are different serial communication channels for transmitting and receiving, the T and the R, and pairs of pins can be used for duplex or both directions style communication. And we have multiple channels that can facilitate that on our board. For us in the lab, it's going to look a lot like what's shown on the screen. Do remember, though, that the data being sent over our USB cable back to our computer is on some of the pins as well. The TX and RX0 are hardwired to that USB connection, and so the same serial data is being sent both places. We have a piece of hardware known as our USART register. It's our universal serial asynchronous receive and transmit buffer. So it is connected directly to some of the ports, and all we have to do is activate it using the some certain register setup commands that we'll dive into more in the future and in future classes. But once that piece of hardware is connected to our output pins, we can use those for sending and receiving communications. So the advantages of using C are because we do have access to these standard input and output functions, such as printf that you used previously in our C programming course. This is very similar. Not every one of you maybe used it, but it's similar to the cout and cin style commands. We have a printf and scanf that perform a similar function. And it allows us to send both numeric and text information. We can also send the contents of variables, get updates on increment variables as we move through loops, things like that. So there are a lot of troubleshooting advantages to having serial communication. So let's talk about using the printf function. You can see an example of it here, just printf and then a string in double quotation marks. You may recall that strings are a C++ concept. We're going to bring that into this course briefly, but as we learn more about how the hardware operates on our board, we're going to eliminate the printf command entirely in future courses and do things at a more hardware level later on. But for now, we can use this functionality to immediately send text like you see on the screen, hello world. And debugging will be the main use of this, although occasionally we will use our serial as our primary output. So we might make, such as we do in Lab 4, a clock where we have seconds and minutes and hours and days, and we can format that information for sending to the what's called the data visualizer through Microchip Studio. We have an ability to basically siphon off the USB data and show it in a text window through Microchip Studio, and our lab will show us how to set that up. As we mentioned, there are 2 pins required for duplex transmission, which means sending in both directions. There's a TX and an RX pin for most devices communicating in this simple serial style. The STDIO library is one of the pre-installed libraries for most basic C language systems, and it gives us access to the printf code for usage. So that's the end of our brief introduction today. Lecture 4B is going to go into the details of how those information packets are actually formatted in a register and sent over the line. But where we're going to start today in the lab is just using the printf command, making sure our microcontroller can communicate and use that to help us troubleshoot as we move through code and create more mechanisms in the similar vein to what we've been doing so far, following flowcharts, creating loops and decisions, reading buttons and switches. And now we have the tool of communicating serially as well.